Good day, I'm Dr. T and welcome to my kitchen table. So today I'd like to work a problem and hopefully I can get this camera to record my paper and we can work on this one together. Okay, so the problem I have, this is kind of a standard, starter introduction to dimensional analysis problem. What is the volume of 1.230 centigrams of nickel? Okay, you're never going to see centigrams in a real application. No one uses that unit, but it's still kind of a cool unit. Okay, so in doing this, we've got a couple of things we need to figure out. First, I am starting out and I have volume. It doesn't say the unit, so I can use anything I would like. I know that I'm probably going to be able to look up density, and that volume from the density will be in milliliters. So if that's the case, it's easiest for me to answer in milliliters. So well, I'm just going to be lazy. I'll answer in milliliters. Also, it might make sense. I may get to translate this later. It depends on what this is. And I just flop numbers down here. So I don't know what the answers are until I do it. Okay, next off, I have nickel. I need a density for that, so I'm going to have to go look it up. So I have chart over here. This is one of my old lab books. And I'm going to look up the density of nickel, and in this particular copy, only 3 sig figs, not good. Okay, I have the density, which is usually given a row, which I'm really bad at writing Greek letters, for nickel is going to be 8.91 grams per milliliter. And basically what I'm doing right now is just plopping all of the data onto the page so I can use it here in the next step. Next thing off, okay, so that's grams, that's milliliters. I like the answer in milliliters, that looks pretty good. I don't like that in centigrams, I can't use it. So I've got a couple of ways of doing this conversion. My favorite way of doing conversions when it's just really simple within the metric system, and I'm not doing too awful much fancy. I start out by making this weird stairwell. I put a blank, and that stands in for grams or meters or whatever your base unit is. And going up, I'm going to go D, H, K, skip 2, M. Hey, look, it actually fit. I could go up 2 more or 3 more and put a G for giga if I want. And these are the symbols for the prefixes. Going down, I'm going to do lowercase. That's not a D. You can tell I'm dyslexic. That's a D. Lowercase d, lowercase c, lowercase m. So deci, centa, milli, micro. By the way, that's a mu, not. The medical folks will do an MC, which I totally understand why they're doing that. However, that is not the symbol. Pet peeve. Down there for in for nano, etc. Okay. So in this case, I've got my 1.230. You'll find that 1.23 is a big number for me. It's 123. Anyways, so centigrams. So I'm going to put my decimal point here on the C. And this is where my centa is. And I'm going to go move it because I want to get this to grams. Because that's in grams. I want my units to match as best as possible. So I'm going to go 1, 2. I'm going to move the decimal point over 2 in that way. Now you notice how it went up, so that means the unit got bigger, but also the decimal point moved right, left. So 1, 2, there's my new decimal point, and of course I always put my safety 0 in there. I don't usually cross my zeros, but it's not a bad idea to cross your zeros. So this is going to be that. Should have left a little bit more room for that. Okay, so now I'm going to do dimensional analysis. There's a couple of ways to do it. I'll show you both. So right off the bat, I want to see what this camera is doing, hence the weird poking of the camera. So I'm going to start off with what I know, and I always start off with what I know. Now sometimes I know more than one thing, so it gets a little bit more interesting. And truthfully, I can do this part in the dimensional analysis. I don't have to do it separate. Quite often I will also. Okay, so I've got this. I'm going to multiply this by a fraction, and this fraction is going to be this guy, because in reality, this is telling me that this is 8.91 grams for every 1 milliliter. And actually, that's a bad way of writing it. The one, that is. Ideally, you just go with the nice, just straight line. It's less confusing. Or 1 milliliter over 8.91 grams. Okay, so I've got my two conversion factors. I can pick either one I want. So what I'm going to do is what you want by what you got. So what I want is milliliters, so I'm going to do the milliliters on top, and I'm going to do the grams on bottom, and then the number goes with the grams. And then I type that mess in my calculator. So 0.0123 times 1 divided by, and I don't need to do that one thing. Okay, so I get that number. By the way, I like my calculators in scientific notation. So what this is really saying is that this equals, and I'm out of room, 0.00138047138. Obviously, I'm not going to leave that. That would be insane. So instead, I'm going to say, okay, let's count sig figs. I have in here 1, 2, 3, 4 sig figs. That doesn't count. That doesn't count. Here I have 3 sig figs. This is why I made that offhand comment to start with. Only 3 sig figs. I'm actually going to lose it on my conversion factor. So my answer is going to be 3 significant figures because this guy's 3 sig figs. This isn't exact. The over 1 is always considered exact. It's just, it's just there. But the number that you count sig figs for is the one that goes with the original unit, and that's going to be this one. Densities are measured numbers. If I didn't want to lose my sig figs here, I would have to go look at a different source for nickel. But I'm not going to, so I lost the sig fig there. So now this becomes 0.00138. That's my last significant number. I'm going to round. Boom, I have that. And let's not forget the units because units are important. And actually, I'm not done yet. I really need to include what they are. And I'm just going to use chemical symbol for nickel. Okay, there's my answer. But I told you I'd do it 2 ways. So I'll do it the other way. And that's called line mole. And I'll skip this step, so I'll build it into the dimensional analysis. So line mole, I'm going to start out with, I'm going to put a line down. This is actually the one I use the most. So I'm going to start out with what I know, and that's going to be my 1.230 grams. Nickel. I always forget to put that in there. And then I'm going to go, okay, so that's not grams, that's centigrams. Let's see if I can get this right. Okay, so now I'm going to need to start canceling out things because notice up here that gram cancels with that gram. I want to do the exact same thing, but first things first, I got to cancel out that centigrams. So I know that there are 100 centigrams for every 1 gram. Now, if I didn't know that, that's why I would use this guy. Okay, so now at this point, my centigrams have canceled. So now I'll bring in my 1 milliliter, really I should say of nickel, for every 1 gram of nickel. Grams of nickel cancel. I'm left with milliliters. I made my line way too long. And it's going to still equal the same thing. And once again, the reason I'm shortening this is these numbers over here, I don't know what they are. That's all a question mark. Because there's uncertainty here. Any uncertainty here would have been translated over. And all of those numbers are just artifacts of the calculator. I do not know what those really are. And thus, they go away. Okay. So, yeah. Let's see. Can the calculator... There? Yeah, we can see that. So, with that said, have a wonderful day and see you in future videos.